Hello my dear students, welcome to classroom. So it's been long. I could not update any video for the past few days, but then today I'm back. I'm back to teach you all, and then I've got a exciting topic. Okay, so this will be the topic for today: extracting of metals law in the activity series. Okay, so before we start the class, let's listen to this soft piece of music which I just discovered. Okay, and I'm so in love with this music right now. Let's listen to it a little bit and let's build up the energy of the classroom, and we'll start. Today I'll not be holding the phone. I want to keep this phone somewhere. Let me keep it somewhere here, and let us enjoy the music. Because if my hands are free, then I can shake. I can move my body. Okay. Let me just enjoy the music. This music is so good. Just found it recently. Good. The video will be longer because I'm listening to the song till the full, but it's okay. We'll start soon. Let's build the energy and then we'll start soon, because we start our classes with full of energy. Okay. Nice. Thank you to YouTube, because had it not been YouTube, I will not have found this music. Okay, and it's all thanks to YouTube. Okay, these days we get good music from Instagram, so the source for this music was Instagram, and from Instagram finally the source goes to YouTube, and everything has been uploaded in YouTube, and even this video will be uploaded in YouTube. So we are living in a digital age. Okay, so everything is being recorded and uploaded in YouTube, and YouTube is a platform which is very, very big. Okay, I just remember one quote which is said by Elon Musk. He said that in the 21st century, when we are living in the age of YouTube, okay, you cannot say you don't know. So make full use of YouTube. Okay, YouTube is there. Everybody uses YouTube. Okay, so learn from YouTube. So people upload. Okay, and you can learn many things in YouTube. Okay, all the good stuffs are in YouTube. So learn from them. Okay, learn anything that you want. Okay, from YouTube. Okay, and even education. Education is the next mode of learning will be online. So we have to be ready for that. Okay, so online is getting accessible thanks to good internet connectivity. Okay, and development. So internet is getting bigger and bigger. Okay, so on this note, let's start our class. So okay, all the stress gone. Now I'll focus all my energy on teaching you this. So hello students, my name is Benatang Paton, and I welcome you all to the channel, and I welcome you all to this channel, Classroom, where we learn together. Okay, so let's start the class. So today's topic, okay, is extracting metals low in the activity series. So in the previous video, we were discussing about how metals are occurred. Okay, so occurrence of metal and extraction metals in general. So there, a general preview has already been given. Today we are going to go deeper. Okay, deeper into the lesson. So let's learn. Okay, so here I have written the activity series of metal. This is very important. Okay, so this family belongs to the most reactive metal. We'll study them separately. Then we have the moderately reactive metal, okay, which will also be studied separately. Today our discussion is on this family, on this group of family. This belongs to the low reactivity series. This family are low reactive in nature, so they are in the low. Okay, they are low in the activity series. So this is called the activity series, okay, of metals. So you are already familiar with this because I have explained to you, okay, in my previous video. So today we'll learn how to extract the metals which are found here, okay, at the bottom of the activity series. Now here, out of these 4 metals, okay, we will rule out the last 2 metals, which is gold and silver. So we will not be studying, okay, we will not be bothering ourselves, okay, about how to extract gold, because gold occurs in free state. So we will not study how to extract gold. Gold is gold, okay, it occurs as it is, okay, with no mixing with any other element. That is why gold is the least reactive element. Okay, then silver also, since silver also occurs in free state, so we will not be studying about we will not study about the extraction of silver and gold. So whose extraction are we going to study? We'll be studying the extraction of these two metals, okay, copper and mercury. So we will be studying the extraction of copper and mercury. All right. So now before we go into the lesson, let me give you the key concept. So concept is very important, class. And then here in the classroom, I want you all to understand the concept, because time and again I've been saying, okay, that concept is king. I always say concept is king. Concept is supreme, because everything is concept. You understand better once you understand the concept. So if you don't understand concept, you will have to memorize, and memorization is not the key, my dear students. Memorization is not the key. I want you to stop memorizing and I want you to learn, okay, by understanding the concept. So there are some key concepts which I will give you first, and after giving you this, okay, it will become so easy for you. Believe me, okay, I'm speaking the truth here. It is very easy once you understand the key concept. So let us dive into the key concept, okay, the concept of how to master this, okay, these extraction topics, okay. So first one, so the first thing that I want to tell you is, concept number one is that remember that metals, okay, they occur in the form of their oxides, sulfides and carbonates. These three you have to remember. What did I just say? Oxides, sulfides and carbonate. Let me just write it down, and as usual I want you to open your notebook, okay, grab a pen or a pencil and write down, because this will serve as a healthy note. And then on this note I want to express my gratitude to my students who are watching this video and who are learning and who are following this rule. I am saying this because I have my own student in my own classroom, and then he regularly watches my video, and I can see that he is developing interest and he is doing better. So I am proud of him, and so I want to be proud of you all, my dear students. So follow this methodology, okay, and I promise you, okay, you will improve better, you will get better, okay. So today one student, tomorrow another student, the third day another student, like that, okay. Slowly these small changes, okay, they will make you big one day, okay. So bring positive changes in your life, and then these small positive changes will make you big in your life. So always, okay, always change for the better and not for the worse. So let's write down the concept. So what I just told you just now is that metals, they occur in three forms. They occur in the form of their oxides, sulfides or carbonates, okay. So metals occur as, number one, oxides, sulfides and carbonates, okay. This is concept number one. Remember that metals, they occur as their oxide form. Metals can occur in their oxide form, metals may occur in their sulfide form, or metals may occur in their carbonate form. These three forms, okay. Remember this, very important. Remember this, okay. Now next point number two, okay. Now point number two is very crucial, because we will be following this order, okay. So point number two is, it is easier to extract metal in their oxide form. Remember this, of the three, oxide, sulfide and carbonate, it is much easier, it is the easiest, you can say the easiest, okay, the easiest extraction method is to extract the metal from its oxide ore. So remember this, let this be the point number two. So it is much, I'll just write much as well, much easier to extract metal from their oxides. Very important. This is one of the most important point, okay, if you ask me, okay. This is also important, this concept is very important. VVIMP, very important, okay, important for exam. So it is much easier to extract metal from their ore. Now there must be a question, okay, in your mind. How is it, sir? It is much easier to extract metal from their ore. How? From their oxide. How? Okay, so I'll tell you how. Now why do we say that it is much easier to extract metal from the oxide? Because once the metal is in their oxide form, all you have to do is heat it, just heat it. Because once they're in their oxide, all we have to do is we heat it, okay, and a simple heat, okay, will bring about reduction, okay, and after reduction you get the metal. Voila, there you go, the metal that you want. Okay, so the metal that we're after, we will get it. So once the metal is in its oxide form, all we have to do is heat it, okay, and then with the introduction of heat, it will get reduced. Reduction means oxygen will be lost, and then what we will get? We will get the metal. And that's how, okay, extraction of metal, okay, in the low series is done. Okay, the same philosophy, the same concept will work for here also, for these metals also. Okay, but today we will discuss about this in the bottom series. So remember, in the bottom series, as per your syllabus, we are not going to study about their carbonates, okay, we'll study about their sulfide only. So the sulfides are given to you. So now let us go into the actual topic. Okay, now before we go into the actual topic, let me give you the formula. Okay, the formula is this one. Okay, this is formula, but let me write it better. Okay, here, so just write on like formula. Okay, why a formula? Because formulas are key. Okay, they are key to understanding things. Okay, so I will give you this formula. The formula is, for extracting metals low in the activity series, remember, we'll be studying only their sulfides, which is how it is given in your syllabus. So you have the sulfide, or you have the metal in its sulfide form. So we have the sulfide. The sulfide we will convert to oxide. Okay, the oxide we will heat it. Okay, which will bring about reduction. And after reduction, what you will get? You will get the metal. So we will be following these 4 steps only. Okay, so let us take the sulfide. So let us first start from we'll start from mercury. Okay, this is mercury and this is copper. All right, Hg is mercury, this is copper. So the sulfide form of mercury is called cinnabar. So HGS. So let's start. Number 1, okay, we'll start for mercury. Okay, in the textbook also mercury is discussed first. So HGS. Okay, HGS. What is this? This is cinnabar. Cinnabar. Okay, cinnabar. So this is the ore of mercury. Okay, cinnabar is a very important ore of mercury. This is the sulfide form of mercury. So what will we do? Okay, we have to first convert the sulfide. This is the sulfide. This is not a sulfide. This is the sulfide. Okay, HGS. This is the sulfide. The sulfur is here. HGS. What we have to do? Follow the formula. We have to convert the sulfide to oxide. Okay, oxide means reaction with oxygen. When reaction with oxygen, when the element reacts with oxygen, they convert to its oxide form. So we have to introduce oxygen here. So we have to bring somebody here. Whom are we bringing? Whom should we bring here? We have to bring oxygen, because only after you bring oxygen, it will convert to its oxide form. Remember, we are here right now. We are here right now. We have to go to this. We have to become this. So I need the oxide form here. I need to get the oxide here. I need the oxide. So the only way to bring oxide, since oxide, okay, is reaction with oxygen, let's bring oxygen. So you bring oxygen. You bring oxygen. Okay, you bring oxygen. So what will happen? This cinnabar, this mercury sulfide will react with oxygen, and what you will get? You get the oxide of mercury, which will be HgO. Yes, you are correct. You guessed it right. Okay, so plus another. Okay, you will get 2 products. The other one is a gas, sulfur dioxide, SO2. Okay, I'll not be bothering myself with the balancing. Okay, balancing I'll just give you the direct. Okay, balancing is easy. Balancing is not very difficult. So balancing you can do, because balancing has also been taught to you. So balancing, assuming that you know balancing, I'll just give you the straight. Okay, because this way is easier. Balancing is not very difficult. It's very easy. I want you to learn balancing. So there has been a video uploaded on how to balance for chapter 1. So you can always go and check that. There I've explained in detail how to balance. So a student of class 10 should know how to balance. That's what I have been saying. So you should know how to balance. Balancing is very, very easy. Just give it a try. Okay, I guarantee you'll be able to do that. So this is, okay, this is what we have got. We have got the oxide. Okay, so we are here. Currently we are here. We are here now. So what we have to do? Now we have to reduce it. Okay, so we'll have to reduce it. We'll have to perform now reduction reaction. Okay, so reduction reaction. So let's go for reduction now. So let's go for reduction. So we'll do reduction. Now we'll go for reduction. What is reduction? Reduction is removal of oxygen. Okay, my dear students, removal of oxygen is called reduction. Okay, remember this one. Reduction means removal of oxygen. Means what? We will remove this oxygen. Okay, इस oxygen को निकाल के फेंक दो, निकाल के बाहर कर दो, separate कर दो. Then it will be called reduction. Okay, reduction. So that's what we will do. Okay, before I forget, the first process has a name. Okay, the first process has a name. The name of the first process is called roasting. Okay, so here you write roasting. I forgot to give you this. This is roasting. Why is it called roasting? Okay, in this extraction series, you will come across roasting and calcination, which are exact opposite of each other. Right now, let me just tell you what roasting is. So roasting is heating the ore in abundant supply of air. Roasting is heating the ore in excess supply of oxygen. Okay, yes, in both the definition I have used different terms, but then they are same. In chemistry, air means oxygen. Okay, abundance is excess only, isn't it? So you know that. So roasting, what is roasting? This is heating the ore in excess of oxygen. Also, it is air. In chemistry, air means oxygen only. So when we heat the ore in abundant supply of oxygen, it is called roasting. And the exact opposite of it, which is when we heat the ore in limited supply of oxygen, will be called as calcination. That we will discuss in detail in the when we study the extraction of metals in the moderate or the middle series. So let's keep it aside for now. For now, you all have to know is roasting. So when the sulfide ore is converted to its oxide form, the process is called roasting. Okay, because the sulfide ore is heated in abundant supply of oxygen. That's why it is called roasting, which gives you the metal oxide. Remember, ये तो metal oxide है. किसका metal oxide? Mercury का metal oxide. The metal of our interest here is mercury. So we got the metal oxide. Okay, we got the metal oxide plus sulfur dioxide. This is a gas. This is a gas. This is a gas. Okay, it will just vanish away. So now next step is reduction. Now we are here. Now we have to convert the oxide to reduction. Okay, so we have to perform reduction, which means we have to remove the oxygen. So we will have to take this one. So take this HgO. But for remember class, okay, remember class, don't forget to write this also. So write this also. So write the sulfide form of mercury, and then what do? You just heat. इसको just गरम करो. Just heat it. Okay. Reduction में all you have to do is heat. Simple reduction. Okay. Just heat it. So heat it, and what will happen? Okay. Reduction is taking place. That means oxygen will get removed. So oxygen removed. Okay. And then the same thing, sulfur dioxide. So this is the metal. This is the metal that we wanted, isn't it? See? There you go. We have just extracted metal from its sulfide ore, which is cinnabar, HGS. This is it, class. My dear students, this is how easy it is, okay? This is how easy it is. And all this time you have been thinking that this is so hard, okay? I did not understand from the class teacher, okay? That's because you never paid attention. But today you're understanding because it is easy, okay? All you needed was to pay attention, okay? So next, we will do for copper, okay? So the sulfide form of copper is copper glance, okay? It's copper glance, so I'll just write it. So Cu2S. What is this? This is the sulfide form of copper. The name is copper glance, okay? These questions, these things you have to know, okay? Their names, the names of their ores, okay? So copper glance, okay? So Cu2S. So let me just make it smaller. It's small than Cu2S, okay? Okay, so is it morning? I don't think so. It's not morning, it's almost 12 only. So Cu2S, so plus same thing, okay? The formula is same. Sulfide, we have the sulfide here, okay? Now we have to get the oxide, okay? So what we do is we react with oxygen, Okay, we react with oxygen. All right, you can pause the video. Okay, you can pause the video and you can do it by yourself and resume the video, okay, to check whether you can do or not. So I want you to pause the video now and do it, okay, then rewind again, then resume again and check, okay, and check whether you did correctly or not, and I'm sure you will have done correctly. So Cu2s, okay, plus oxygen, what will happen? You'll get the oxide of the metal, so you'll get the metal oxide. So you'll be getting the metal oxide, so the metal is copper, so you'll get copper oxide, Cu, oxygen, and then what you'll get sulfur dioxide, which is the gas, okay. So sulfide to oxide, okay, we are here in the second stage, okay. Now what do? We will have to go for reduction. Reduction means removal of oxygen. So let's remove the oxygen. So the process is called reduction. Remember, second step is called reduction, okay. The first step is roasting. This is roasting, okay, class. The first step is roasting, okay. There are only two steps for extracting metals at the bottom of the reactivity series. First is roasting, second is reduction. Two steps only, okay. So roasting done. Now we'll go for reduction. So reduction, which is removal of oxygen. So we'll take copper oxide, CuO, but don't forget to write the sulfide form of copper, which is Cu2s. And then what will happen? Heat, okay. We are just heating it, okay. Just simple heating, okay, is enough for the metals which are found at the low of the activity series. Just simple heating will do it, okay. So by heating it, what happened? Oxygen gets reduced, so oxygen is removed. So what you get the metal that you desire, which is copper metal, and then what you'll get sulfur dioxide. There you go, okay. This is it, my dear students, this is it, okay. So this is how easy it is to extract the metals which are found at the bottom of the reactivity series, okay. So now we will discuss how to extract metals which are found at the middle of the activity series, okay. So let me erase this and then we will continue. So extracting metals in the middle of activity series. So it should be activity series here, activity series. So let's learn how to extract metals which are found in the middle of the activity series. So these three metals, okay, these belong to the family of middle reactivity series, okay. So whereas this one, they belong to the family of very high reactivity series, okay. So these three metals. Now of these three metals, as per your syllabus, we will be studying only about zinc, okay. So this is our prime interest. We'll be studying about zinc, how to extract zinc. Now remember the concept which I gave you earlier. The concept is that metals, they occur either in their oxide, their sulfide, or carbonate. So let's rewrite again, okay, but this time the pattern will change a little bit, okay. So the concept is, we know that metals, they can occur in the form of their sulfide, okay. This is important, you write down this. They can occur in the form of their oxide, or they can occur in the form of their carbonate. You already know this. Now if it occurs in the form of the oxide, then simple heating, okay, just heat it, and then, okay, what you get? You get their metal oxide. The target is to achieve the metal oxide, isn't it? The target is to reach to the metal oxide, okay. Now if it is sulfide, remember, okay, how we extracted metal in the middle, in the low activity series, okay. So if it is sulfide, then what you do is you just perform roasting. So just roast the ore, okay, and then what you'll get? You will get the metal oxide, okay. So from the sulfide ore to reach to the metal oxide, you just have to heat the ore. You have to burn the ore in excess supply of air. And if it is carbonate, then what you do? You will have to go for calcination, okay, which I'll be explaining much later. Calcination, which is heating the ore in limited supply of air, which will bring you to metal state. So the target is to reach the metal state. Remember the formula: from sulfide to oxide. From oxide, you have to go for reduction, remove the oxygen, and then get the metal that you desire. Okay, so we have reached this oxide form. Now what you have to do is you have to perform reduction. From here, all you have to do is perform reduction. Okay, and after you do reduction, you get the metal. This is the formula. Okay, for the elements, for the metals at the middle of the reactivity series, this is the formula. Okay, so using this formula we will do. Okay, it's very easy. So let's remember this formula and let's do this. So it is zinc. So zinc, okay, zinc, we will be studying zinc sulfide and zinc carbonate. Okay, so let's first take zinc sulfide. So let's take zinc sulfide, ZnS, zinc sulfide. Okay, the sulfide form of zinc. The common name is zinc blende. So zinc blende, this is the name of the ore. Okay, now you know that for sulfide ore, roasting, okay, roasting is done. Roasting means heating the ore in excess supply of air. Okay, so we will heat this, okay, in excess supply of air. Air means oxygen, so plus O2. So this process is called roasting. Okay, roasting, we just discussed earlier, which is heating the ore in excess supply of air, abundant supply of air. Okay, so this one. Okay, then what you'll get, you will get the, what is our target? Our target is to get metal oxide, isn't it? We are to get metal oxide, so you get the metal oxide, which is ZnO. Okay, plus you get sulfur dioxide. This is the metal oxide. Okay, this is the metal oxide. Okay, let me help you, my dear students, and this is my trick, okay, on how I remember this. So when I was a student, so it was not easy, okay, remembering roasting and calcination. Calcination not yet, okay, discussed, but let me help you remember how to remember roasting. Roasting is, see, we go for chicken roast and all that. So if you are going to roast a chicken, where will you roast the chicken? In a closed room or in the open garden? What is your answer? Would you roast a chicken in your room, in a closed room with the ventilation closed, doors closed, or would you roast the chicken in an open garden? The answer is in the open garden. In the open garden, there is oxygen, there is wind. So, okay, whereas if you do it in a closed room, what happens? The aroma will spread around. So your clothes will smell of it. Your body itself will smell of the chicken roast, isn't it? So you will never do chicken roast in your room. You will do it in the open field, in the open garden, where there is abundant supply of oxygen, where there is surplus supply of oxygen. So remember, this is one trick, okay, tip to remember roasting. So remember roasting very well. And then the opposite of roasting is calcination. So if you know roasting very well, calcination becomes very easy to remember. Okay, so that's how I remembered, and I'm sharing my idea to you. Okay, so this is for zinc sulfide, which is zinc blende. Then we will do for zinc carbonate. Okay, because zinc, okay, zinc is found in its carbonate form also. So let's take zinc carbonate. So zinc carbonate is ZnCO3. Okay, so here we will be doing calcination. Calcination, this is new. This is something new, isn't it? So what is calcination? So let's spend some time to understand what is calcination. So calcination, write down the definition: heating the ore in limited supply of air. In limited supply of air. Of air means of oxygen. Okay, of oxygen is known as calcination. It's known as calcination. These are two very important definitions they ask in the exam. Okay, calcination, and the other one is roasting. Okay, roasting. So you should be thorough with these two. Okay, so remember, calcination is heating the ore in limited supply of air. Okay, that means it is deprived of oxygen. So you will understand clearly here. So we have zinc carbonate, and what are we going to do here? We are going to perform calcination reaction. So unlike here, okay, this step will be missing here. Got it? So directly what you are doing, you are heating. Oh, here it's heating. Okay, heating, burning, heating. Nah? So here also heating. But do you see any change here? We only have one reactant, whereas we had two reactants, zinc sulfide and oxygen. Here, since it is calcination, oxygen will not be used. Okay, no oxygen. Okay, whatever oxygen it has, we'll use it. So zinc carbonate itself is bringing oxygen though. Okay, so whatever oxygen it has trapped in its molecule, that will be used. So no need for us to supply external oxygen. It already has got oxygen in it. So that's why this technique is called calcination. Here, whatever the ore is bringing, that oxygen will be used. But here, external supply is given, okay, because the ore did not bring it. It's zinc sulfide. There is no oxygen here, okay. But here in zinc carbonate, it itself is bringing oxygen. So whatever it brought, we will use that. Okay, so no external supply of oxygen from our side. That's why this process is called heating the ore in limited supply of air. That is called calcination. So what will happen? So reduction. So now it will convert this metal oxide. This is the metal oxide. So we will get the metal oxide. Metal oxide. So what do you think we'll get? We'll get ZnO plus what do you get? We'll get carbon dioxide, CO2. Okay. Here we are getting sulfur dioxide. Here we'll get carbon dioxide. Okay. So roasting for sulfide ores, calcination for carbonate ores. So we are here now. We are here now. So we are here. We have already achieved this stage. So what is left for us? We'll have to go and perform reduction. So now we'll go for reduction. So reduction of the metal oxide. Okay, we will only reduce the metal oxide. So whether you take this or you take this, it is same. So let's take any one. So let's take the metal oxide, which is ZnO. Now this is reduction. Let me write reduction. Now we are going for reduction. What is reduction, class? Anybody? What is reduction? Reduction is removal of oxygen. So our primary goal is to remove this oxygen. So we have to remove this oxygen from the metal oxide. So we will remove the oxygen from the metal oxide. So ZnO. Okay. Now, so plus. Now this is the second difference. Okay. Now when it was metals of low reactivity series, which was copper and mercury, what we did was that a simple heating was enough. Just heating the metal oxide, okay, and then what we got? Oxygen got reduced. That means oxygen got removed. But now we are discussing metals at the middle of the activity series. So for them, okay, it will not be as easy as for us it was for these metals, because these are metals of low reactivity. It was quite easy, but for these metals, these are more reactive than this metal, so things are different for this. So in order to remove oxygen from zinc, okay, right now zinc is strongly bonded with oxygen. To remove oxygen from zinc, it won't be that easy. Okay, so we need a reducing agent. Okay, and the reducing agent this time cannot be heat. Okay, which worked for the low reactivity series. For middle reactivity series, remember, my dear students, it cannot be heat anymore. Okay, we need something stronger. We need someone who is more reactive than zinc. Okay, so we need someone who is more reactive than zinc to remove oxygen from zinc. Or else though, if we choose someone who is weaker than zinc, then oxygen will not, then zinc will not let go of zinc. Zinc will not let go of oxygen. So we need a metal which is, or a substance which is stronger. Okay, we need a substance. We need an element, can be a metal or non-metal. Okay, who is stronger than, who is more reactive than zinc, so that okay, oxygen can be removed. Okay, so that the element can take away oxygen from zinc. Okay, so who will it be? Who will it be? Whom do you think it will be? So we will select an element, okay, which will occur higher than zinc. So what we are selecting? We are selecting a carbon. Okay, we are selecting a carbon. So we'll be selecting carbon. We'll be selecting carbon. Okay, carbon. The name of this carbon is coke. Okay, so this is coke. C-O-K-E, coke. Okay, so coke. So we are selecting carbon. So coke is a form of carbon. Okay, coke is amorphous. It is powdery. Okay, it is powdery in nature. It is powdery in nature, and it is porous. Okay, it is porous and it is powdery in nature. Okay, so coke is a form of carbon. Okay, now where does carbon occur? Here though there is no carbon, I have not shown you carbon. Okay, and then we're using carbon. That means carbon is more reactive than zinc, is it not? If carbon is not reactive, more reactive than zinc, then how can it take away oxygen from zinc? Zinc will not let go. Zinc will not allow a weaker element to take away oxygen. Only a stronger element, okay, can remove oxygen from zinc. So carbon is more reactive than zinc. So where does carbon occur? Definitely carbon occurs above zinc. So where does carbon occur? I have not shown you here, but let me show you where carbon occurs. So carbon occurs here, okay? Carbon occurs here, immediately above zinc. That's why we're using carbon. So carbon is used because carbon is more reactive than zinc. Being more reactive than zinc, carbon can remove oxygen from zinc. So now what will happen? The reaction will take place, and then zinc, okay, oxygen gets detached from zinc. So zinc is all alone. This is the metal. Is this not the metal that we're after? Yes, we're after zinc. So we got the metal. Okay, and then we get another byproduct, which will be carbon monoxide. This is carbon monoxide. Okay, so my dear students, this is how we extract metals which are found in the middle of the activity series. All right, now sometimes for reducing displacement reactions are also used. As of now, we have been using reducing agents, okay, to remove the metal oxide, to convert the metal oxide to the metal. So we have been using reducing agent only, okay, but we can also use displacement reactions. So there are two displacement reactions which are discussed in your textbook. We'll discuss them one by one, okay. It is still part where those two reactions are still part of the middle reactivity series. So we'll discuss them now. So we can also use displacement reactions, okay, instead of reduction reaction to convert the metal oxide to metal. Remember that. So let us have a look at those. So one of the reactions given to you is this one, manganese oxide, MnO2 plus, now see, this is manganese oxide, okay, this is the oxide of manganese. The name of this is pyrolusite, okay. Now this is the metal oxide. Manganese is a metal, and this is the oxide of manganese, manganese oxide. We want to remove this oxygen, just like we tried removing oxygen from zinc, for which we chose an element which is more reactive than zinc, which was carbon, okay. So that was reduction, okay, till that much reduction. Now we are changing the new topic, okay. Now do we have another technique, okay, for converting a metal oxide to its metal besides reduction? The answer is yes. And so this is the first reaction that we are studying. So now we will not be using reducing agent, okay, we will not be using reducing agent. Rather we will be studying displacement reaction. So now we'll be studying displacement reactions. So with the help of displacement reaction also, okay, we can convert a metal oxide to its metal. Now there must be a question in your mind, sir, what is displacement reaction? It's a very, very important reaction in chemistry. Let me tell you what is displacement reaction. In displacement reaction, a more reactive element displaces a less reactive element. For example, this duster and this marker, okay. So this duster and this marker are together. So what happens is that, and let's say my fist is more reactive than this marker, okay. So what will my fist do? My fist will go and displace this marker. So this marker will get displaced, and then the bonding will be done between my fist and this duster. So what happened to the marker? The marker got displaced. Okay, by whom? By a more reactive element, okay. So since this element was more reactive, it displaced the marker. The marker, being lesser reactive, got displaced by my fist. This is how displacement reaction works. A more reactive element displaces a less reactive element. So in displacement reaction, a more reactive element displaces a less reactive, okay, a less reactive reaction, a less reactive element. So displacement reaction works like that. Okay, so this is MnO2. Now where does manganese occur? Now we have to find this manganese in the reactivity series. Now it is not here. Search for manganese, you will not find Mn. It is not there. Okay, so where is manganese? Manganese is here, my dear students. Manganese occurs here, just above carbon but below aluminium. Okay, so manganese occurs below aluminium. So now I want to displace manganese. That means I want to chase away, I want to remove manganese. Okay, I want to remove manganese, and then we are going to perform displacement reaction. That means, don't I need a metal who is more reactive than manganese to displace manganese? What is your answer? Okay, let me repeat again the question. Don't I need a metal who is more reactive than manganese to displace manganese? Because in displacement reaction, a more reactive element displaces a less reactive element. So what is your answer? Yes, we do need a more reactive element, okay, an element which is more reactive than manganese if we want to displace manganese. So whom should we go for? Okay, manganese is here. Okay, so should I select zinc? Should I select Fe? No, my dear students, no. Now why can't we select? Why are we not selecting these metals? We will not be selecting these metals because they occur below manganese. Even carbon is below manganese. That means manganese is more reactive than carbon. So carbon cannot displace manganese. If carbon cannot displace manganese, forget about zinc, Fe and these metals. Okay, out of the question. Okay, we cannot be discussing about these metals because they are below manganese. So we need, okay, a metal who is above manganese. So whom can we use? Whom should we use? We can use aluminium. Aluminium, okay, is above manganese. So aluminium can easily displace manganese because aluminium is more reactive than manganese. So aluminium is what we will choose. So we'll select aluminium. Okay, so now the reaction will take place. Aluminium being more reactive than manganese, what will aluminium do? Okay, aluminium will go and displace. Aluminium will go and chase away manganese, telling, chut, go, जा यहाँ से, go. Okay, so aluminium will go and displace manganese. So manganese will have to go. Okay, manganese will have to go. So manganese goes and now it stays alone. Okay, so manganese got displaced. Okay, my dear students, remember, this is not reduction reaction, this is displacement reaction. Understand the story. Okay, this is displacement reaction happening, not reduction. Okay, so manganese got displaced by aluminium. So now, since manganese got displaced, who will form a bond with oxygen? Aluminium will form a bond with oxygen. So now you will get Al2O3. Okay, Al2O3. Okay, plus again a lot of heat. Okay, tremendous amount of heat. Okay, tremendous amount of heat. So much heat that this manganese, okay, we get it in molten state, which means in liquid state. Okay, molten state. Okay, in molten state we get, because of the tremendous amount of heat which is released in this reaction, we get the manganese metal in liquid form in its molten state. That much amount of heat is released. Okay, that's why these reactions are highly exothermic. They are highly exothermic. In chemistry, exothermic reactions are those chemical reactions which give out a lot of heat in the course of the reaction. Reactions which proceed by giving out a lot of heat are called as exothermic reactions. Okay, so remember this. So this is one of the reaction which was given in your textbook. Now there is another reaction given for iron oxide. So let's try that also. So that also is about displacement reaction. So let's try that. So Fe2O3. So this is iron oxide. Okay, Fe2O3. Now again, displacement reaction. So let's go and find iron. Where is our iron? Iron is here. Iron is here. So this is displacement reaction, my dear students. So we need an element which is more reactive than iron to displace iron. Our goal is to chase away iron. Our goal is to displace iron. So whom should I select? I can select zinc also, I can select carbon also, I can select manganese, I can select aluminum. I'll select aluminum. Okay, I will select aluminum. So that is what has been done in your textbook. So I'll select aluminum. So I'm taking aluminum. Okay, so aluminum being more reactive than iron will displace iron. Okay, so iron gets displaced. So here is our friend बेचारा iron. Okay, अकेला पड़ गया ना. So iron here. So this is the iron. Then aluminum will go and form a bond with oxygen. So you'll get Al2O3 plus same. Okay, heat, tremendous amount of heat. Okay, so this is again a highly exothermic reaction. The heat is so much that this iron will be in its molten state. So here also you get molten, M-O-L-T-E-N, molten iron, molten state. Okay, it is in its molten state, it is in its liquid state. Now this reaction is also known as thermit reaction. A very important term, thermit reaction. Okay, remember this, it may come in MCQ, thermit reaction. Okay, this particular reaction, okay, this particular reaction of iron oxide with aluminum is known as thermit reaction. Now why is it important? It is important because this is the technique, okay, which is used to mend, to repair, to mend, or which means to repair, na? To repair what? To repair cracks, to repair cracks in railway tracks. If there are cracks in railway tracks, that is very risky, is not? So that is very bad for the train. So they have to mend it. So the technician will come and then he has to repair it. So the technician will perform this thermit reaction. So the molten iron, okay, and the iron which is in the molten state. Now the rail tracks are also made of iron only. So the molten iron will go and fill up the gap, and then it will be like, well, it will be repaired, na? So it will be like brand new again. So the railway tracks are mended. Okay, the cracks in the railway tracks are filled using this process. That's why it's called as thermit reaction. Okay, not only the cracks in railway tracks, but cracks in big machines. Okay, cracks in whenever cracks develop in big machines, we are talking extremely big machines. Okay, the same reaction, this same process is used. So this process is very important. Industrially, this is a very important process. So this is why you have to remember this. Okay, it's already mentioned in your textbook also. So this is it, my dear students. So I hope you understood. Okay, I hope you understood whatever is discussed. Okay, the advantage of recorded classes is that you can always rewind and watch again. So I tried my best to make it easier. The video is a little longer, but I'm sure it is long because detailed explanation, okay, has been given. So I believe that you have understood. So before I go, okay, let me give you one question. So I want all of you to participate by giving the answer, in the comment box. Okay, because participation, okay, participation is important. So let me give you the question. The question for today: in general, the number of electrons in the outermost shell, okay, this is shell of a metal atom is, the options are option number A 1, option number B 1, 2, 3. Option number C, 5 to 8. Option number D, 8. So you please comment the answer in the comment box. So the question is, in general, the number of electrons in the outermost shell of a metal atom is how much? Is it 1 electron, 1 to 3 electron, 5 to 8 electron, or 8 electron? Okay, so you give me the correct answer. Okay, you give me the correct answer in the comment box. So with this note, I thank you all, my dear students, for tuning in and watching this video, and I'll see you again in the next video. In the next video, we'll discuss how to extract metals which are found in the high reactivity series. Okay, the procedure for finding them is extremely different, totally different. So it's going to be another exciting video. So stay tuned and watch that video also.